Welcome to the Lionhearted Academy. My name is Richard Tai. Today we're going on our 14 lessons in trigonometry. 14 lessons. Today we're switching topics to a new topic called the functions of any angles. So far we have only talked about trigonometry functions of the angles between 0 and 90 degrees, the acute angles. But as we know, in applications we usually have more. We have to work with not just right triangles. We have to work with any other kind of triangles as well, and angles greater than 90 degrees or even less than 0 degrees. So there's a lot of other angles that we have not talked about yet. So today we're going to start to investigate how do we understand the sine, cosine, tangent, and how do we realize those functions for angles greater than 90 degrees and then other than acute angles. Alright, well, let's start with an ordinate, a coordinate plane. Okay, we have the x-axis, we have the y-axis. The x-axis is the horizontal axis and the y-axis is the vertical axis. Okay, and you have the origin in the middle here. Okay, so if we pick any point P, okay, it has a certain distance. It has a distance. Let me go ahead and draw a diagram here. So any point P, it has a distance to the origin, and it has two distance. One is the distance from the y-axis, from the x-axis, excuse me. So this point P, the distance to the y-axis, to the x-axis, is called y. This distance is the y coordinate, which is also called the ordinate. And the distance from P to the x-axis, or to the y-axis, okay, is called x. It's called x, and that's called abscissa. Okay, abscissa. You may have heard that before, or you may not. This is so again, for point P, okay, the distance from point P to the y-axis is called x. It's called abscissa. A-B-C-S-C-I. And the distance from the point P to the x-axis is called y. It's called the ordinate. So those two are very important values because this gives us the value, or gives us the coordinate of any point on the rectangular coordinate system, which is x and y. Well, we are very familiar, so we count the horizontal units, then we count the vertical units. That's the x units and y units, and then if we end up at point P here, it has x and y coordinate. Okay, so for example, if P is 3, 4, then that means x is 3, y is 4. Then there's also a radius vector. R is the radius vector. Okay, it's the distance from the origin to the point. So that's called a radius. Okay, radius, let's call it radius vector. Now, we haven't really talked about what is a vector, but we will do that a little bit later. So those names may not be familiar to you because most mathematics books probably they don't talk about it. Maybe, but if you go to older books or more specialized books, they will go ahead and use those terms. But it's good for you to know them. All right. So and now let's remember the quadrants. We have quadrant 1 here. We have quadrant 2. We go counterclockwise, and down here we have quadrant 3. And then here we have quadrant 4. So as we go counterclockwise, we go through the 4 quadrants. 1, 2, 3, 4. Now the primary reason for the 4 quadrants is that primary distinctions for the 4 quadrants, the different sign for the abscissa and ordinate value for the x and y value. So in quadrant 1, if you can see in quadrant 1, both x value and y values are positive. In quadrant 2, x becomes on this side, right? Is to the left of the origin, and when it's to the left of the origin, x becomes negative, but y values remain positive because still on the positive side above the origin. In quadrant 3, all the points will have a negative value for x and negative value for y. And in quadrant 4, the x becomes positive and then y value is negative. Okay, so this is a very important fact that we will be using throughout our lessons here. Is the quadrant 1, both x and y values are positive. In quadrant 2, our x values are negative, y value is positive. In quadrant 3, both x and y values are negative. And in quadrant 4, x value is positive and y value is negative, because x here is positive x-axis. Here below the y value, the y-axis is below 0, below the origin, so it's negative. Okay. And you probably remember we talked about initial positions and then terminal sides, initial positions, initial side and terminal side of an angle, right? So what we have is, if when the angle is in standard position, the initial side is always going to be on positive x-axis. So it's always going to be start from here, and so the rotation for it, therefore it becomes a rotation, right? So when we draw any kind of angle, we have any kind. It's actually a rotation. That's why when we call rotate, that's why it's actually called radius. That's one of the reasons why it's called radius, because when we create a rotation, we're creating a circle, and that distance from the center to the edge of the rotation is radius. That's why this R is called radius sector. So as you can see now, we can create any kind of radius in any degrees that we want, because from 0, remember this is 0 degree and 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees and more. So when we rotate counterclockwise, the direction is positive. When we rotate clockwise, the direction is negative. Okay, but the terminal side, once the terminal side is settled down, we don't really worry about the direction, because we can rotate, we can reach the terminal side either through the positive rotation or negative rotation. Just again, so let me write this as positive rotation. Excuse me, positive angles is counterclockwise. So it goes like this, and the negative angles is clockwise. And it goes like this. Okay, I should say it goes like this. Alright. So, well, where's our angle? Well, if you look at this, it is a right triangle, isn't it? Theirs is the right angle between the x and the y, between the abscissa and the ordinate. That's the right angle. And this is one of our acute angle. Of course, we have two acute angles, but we're going to focus on this acute angle that's formed between the x-axis and the radius. Okay, so this angle is going to be called theta. And if we look at this, now we can see that this is not just more than just a triangle, because we can go ahead and rotate this and still create the same ratios for sine, cosine, and tangent by looking at this. So when we extend this r, okay, this radius down to, for example, 0 degree. Now we have never talked about what is the sine, cosine, tangent of 0 degrees, or what's the sine, cosine, tangent of 90 degrees. So let me go ahead and show you physically how what's going on. Okay, let's take a look at some examples of the rotation angle. So R is going to be, my blue side segment is going to be R. So if I rotate, okay, let's say I stop at the first quadrant. Alright, I'm going to form an angle, okay, angle theta. So this side is going to be by R, well, which corresponds to our hypotenuse, basically, previously. And the x-coordinate is going to be here, it's going to be green. And for this point, it's going to be y, right? But it depends on the terminal point. So if I know the terminal point, then I know what my x and y is, and you know that this side is going to be x and this side is going to be y, right? So our theta is going to be look like this. That's in quadrant 1. Now what happens if our angle is in quadrant 2? Okay, so let me draw an angle in quadrant 2. What will happen if I have my angle in quadrant 2? So I start from my initial side and I rotate, and then I end up somewhere here. So this is the terminal side. This is the terminal side of my angle R, my angle theta actually. So this theta is going to be here. This is a positive angle theta. So the point P again has x and y coordinates, right? And what's this y coordinate? The y coordinate is the distance from this point down here. That's y, and the x coordinate will be the distance from the point back to the y-axis, so it will be this distance. Alright, so let me just use a different color here. So this is y here, and this is x here, and this is a right angle. So for theta here, even though theta is not inside the right triangle, but it still has that x and y and r coordinates. x and y coordinates and related with r. So everything still relates, even though you think, oh, what, the theta is not inside the right triangle. That's true, but this angle theta is related to this acute angle as well, and then we will see later. Now what about is in third quadrant? Okay, let me draw another. Let's go ahead and take a look at what happens if it's in third quadrant. So if it's in third quadrant, the angle is going to look something like somewhere here. Alright, somewhere here. Okay, that's so this angle theta is going to rotate from the initial side all the way to third quadrant. There's going to be a terminal point here, P, which has point x and y, and there's a radius. And the y distance is going to be the distance from here to here, and you notice that distance should be negative. Now why is that? Because in third quadrant, and this distance is negative as well. So x is here and y is here. Both of them should be negative. X and y should be negative. Now why is that? Because x is to the left, right? To the left of the origin. The origin is here, so going left is negative and going down is also negative. So here in second quadrant, the x is negative but y is positive because it's going up. Alright, so that's how you determine this. And then if you're in quadrant 4, I can go ahead and show you one more time. And in quadrant 4, you will have basically the same thing. Let me go ahead and scroll up a little bit. So rotate, positive, rotate. Okay, my graph is a little off, but it's okay. So this is in quadrant 4. Okay, so in quadrant 4, my angle is going to rotate all the way here, so that's angle theta. And this is the point on the terminal side, x, y, and this is the radius. The radius again is the distance from the center, from the origin to this point. Alright, and so where is x and y? Well, x in this case is going to be positive. It's going to be the green segment here, and then y is going to be a yellow, the red segment here. Again, they always form a right triangle, don't they? Okay, they always form a right triangle. So that's why we're extending. We're basically still using the right triangle definition, but we're going to extend everything out to something that's other than a right triangle, because now we know that we can extend our right triangles more than just we don't have to limit ourselves just with the angles inside the right triangle. So let's take a look at how we deal with sine, cosine, and tangent. Okay, so the sine of any angle. Okay, in the past, if we go back to the first quadrant triangle, if sine is always the opposite leg divided by the hypotenuse, and here is still going to be the same thing. Here is going to be the ordinate divided by the radius, so it's going to be the ordinate divided by the radius. We're just replacing them with a different name because they are different now, so it's y over r. It's y over r. Excuse me. Cosine theta is going to be abscissa divided by the radius. Is the adjacent leg divided by hypotenuse, so it's x over r. So you have to think about what's adjacent. Well, adjacent is going to be x. X is adjacent, and then r is the hypotenuse. So that's what sine, cosine, and tangent will be defined as. So tangent in this case is going to be the ordinate divided by abscissa, which is going to be y over x. Okay. Now, so same thing for secant theta. Secant theta is going to be the radius, the hypotenuse, r divided by. Okay, let me go ahead and write it out. It's going to be radius divided by the abscissa. So it's going to be r divided by x, and cosecant of theta is going to be radius divided by the ordinate value, which is r over y. Alright, and cotangent of theta will be radius, oh no, not radius, I'm sorry, will be the abscissa divided by the ordinate, which is x over y. So this will be extension of what we have learned already. Okay, extension of what we have learned. Let me rewrite this, r over x. Okay, extension of what we have learned. But as you can see, we're expanding a right triangle to all 4 quadrants of the coordinate plane, which will cover all the angles. It will cover every angle from 0 degree to 360 degrees and beyond. Okay, and this is the basic definition for sine, cosine, tangent, secant, cosecant, cotangent based on this. So let's take a look at some examples. Now the first example I really wanted you to consider is 0 degrees. Okay, so let's take a look about so if I start with 0 degrees, right? Excuse me. Okay, so this is my radius. Okay, this is my radius. Now if I go ahead and do my 0 degrees, that means I am not moving at all, right? I'm not moving at all, and so I'm gonna pick a point here. This is gonna be my point on that terminal side. This is the origin. Okay, so this is my 0 degree. Well, in this case, what is the radius? The radius is, so P is the terminal side on this terminal side. P is the point on the terminal side, excuse me, and we're considering theta equal to 0 degrees. So let me put that as well. So that means the coordinate for P, well, this is the x-axis, so whatever point here, it would just be x. But what is the value for y-axis? Because it's on the axis, so it doesn't matter where I put my point, the ordinate will always be 0. The y value will be 0. And radius is the distance from 0 to P. But in this case, the radius is simply equal to the x value. Okay, so now let's go ahead and consider sine of 0 degree then. Now sine of theta is y over r, right? It's y over r. But what is the y coordinate here? Y coordinate for 0 degree is 0 and r is x. Well, I don't know what x is, but that doesn't really matter because 0 divided by x is 0. So that's why sine of 0 degree is equal to 0. What about cosine 0 degree? Well, cosine 0 degree is x divided by r, and then x is just x, but r happens to be the same as x as well, so that will be equal to 1. So now we're able to find what's sine of 0 degree and cosine 0 degrees. Before, we couldn't do that in a right triangle, because in a right triangle you don't have any angle of 0 degrees, right? Right, what about tangent of 0 degree? Well, tangent of 0 degree is y over x. Okay, but y again is r, so it doesn't matter what x is, it's also equal to 0. Okay, then let's do secant of 0 degree. Secant is r over x. So r and x happen to be the same, so x over x, so it's 1. Okay, is x is 1. What about cosecant of 0 degree? Well, cosecant degrees is r over y. No, so r is the same as x, but y is equal to 0. And when you divide by 0, whoa, that's something strange. Can we divide by 0? No, we can't. So when we divide by 0, it's undefined. So the answer is, is undefined. Undefined. Okay. What about cotangent? Cotangent is going to be x over y, right? So it will be x over 0. So again, it's going to be undefined. Undefined means there's no answer. Okay, it's not defined. We cannot divide by 0. Mathematically and physically, it just doesn't make sense when we divide by 0. Alright, so let's take a look at another example. Let's look at 90 degrees. Okay, let's say that be equal to 90 degrees and see what happens. Alright. Okay, so let's draw a 90-degree angle here. Okay, let me see if I can. Okay, 90-degree angle is going to be right here on the y-axis. Right there on the y-axis. I didn't draw it very well, so let's try again. So it's going to be here on the y-axis, right? So let me pick a point here, point P. Now, because it's on the y-axis, this is origin or, so the x value is going to be 0, and then there will be a certain y value. I can let that y value be whatever. But in this case, this theta is equal to 90 degrees. It's a right angle. And the radius is the same as y. Okay? So let's go ahead and take a look at what's the sine of 90 degrees. Well, sine is y over r. So this is something that you'll have to remember is y over r. Now y and r happen to be the same thing, so it's equal to 1. Alright? What about cosine of 90 degrees? Well, x becomes 0 because when you turn this way, there's no x coordinates. X coordinate is x over r. So, but x equal to 0, y r is equal to y, so 0 over y is 0. All right, and tangent of 90 degrees is going to be y over x. Well, but y is just the same as y. There's a value of y here, but x becomes 0, so y divided by 0 is undefined. Okay. What about secant of 90 degrees? Secant 90 degrees is going to be equal to r over x, and then r is just y, but x is equal to 0, so it's also undefined. Okay. Cosecant of 90 degrees will be equal to r over y. Alright, radius over y, so it will be y over y, it will be 1. Okay, and cotangent of 90 degrees will be x over y, and x happens to be equal to 0, so the whole thing will be equal to 0. So now we are able to find the definition of 90 degrees and even more. Okay, and even more. Now, so let me give you one more example of any angles here. We're just gonna make up some angle here. So let's say we have an angle somewhere here, okay, and we have a terminal point. So let's say this P is equal to -6, 4. Let's do 5, -6, 5. Okay, so as you can see, the x coordinate from here to here is -6, and the y coordinate is positive 5. So x is equal to -6 and y is equal to positive 5. Alright, so this angle theta here, we can find out the sine of angle theta by using y over r, so which would be 5 over r. Oh, and I forgot, how do we find r? I forgot to mention, how do we find r? What's the relationship between r? Well, this is a triangle, is it? Is x, y, r a right triangle? Yeah, there's a right triangle. And so to find the third side, we need to use what? The Pythagorean theorem. So it's x squared plus y squared equal to r squared. So let's find r first. So -6 squared plus 5 squared equal to r squared. Okay, so 36 plus 25 is equal to r squared, so r squared is equal to 61. So r happens to be square root 61. Now 61 I think is a prime number, so we can't reduce it. So y equal to r, y over r would be 5 divided by square root 61, and then if we rationalize it, it will be 5 square root 61 over 61. Alright, then let's do cosine theta. Cosine theta is x over r, so x is -6 over square root 61. So reduce, rationalize this, it would be -6 times square root 61 over 61. Now when you rationalize again, you multiply the denominator and numerator by the same radical. Alright, tangent would be y over x, right? So it would be 5 divided by -6 or -5/6. Okay, and secant of theta would be equal to x over r over x, r over x, which would be square root 61 divided by -5. Alright, and cosecant of theta would be r over y, so it would be square root 61 divided by 5. Oh, okay, I made a mistake here. It was -6 for x. And the last one, cotangent of theta will be x over y, so it would be -6 over 5. Okay, alright, so that's basically how we go ahead and deal with this kind of situation. So we'll do some more example next time, and then we'll continue our lesson. Thank you very much for joining us, and please leave any comments and questions in the comment section below. Alright, we hope to see you next time.